this video I want to further our discussion of the pentose phosphate pathway and talk specifically about NADPH and glutathione and how they act as antioxidants and how the pentose phosphate pathway is involved. So we said that the pentose phosphate pathway makes NADPH, and we said that NADPH provides reducing power. Now, what did we say that reducing power was useful for? We said it was useful for biosynthesis, but it's not just important for biosynthesis. It can also be used to protect biomolecules from oxidants. Now, what are oxidants? They're oxidizing agents, right? It's just another term for them. Oxidants oxidize things, okay? Now, why are they relevant is because oxidants can destroy biomolecules. Our cells are made up of biomolecules. If they're destroyed, cells die. If cells die, the organism dies. So this is why this is relevant. Not relevant, relevant. So how does this actually happen? How does NADPH, how is it involved in acting as an antioxidant? Well, you call this dude called glutathione. Okay, so glutathione, of course by dude, I mean a molecule. So glutathione is a tripeptide containing cysteine. So tripeptide means it's made up of 3 amino acids, right? Tri meaning 3. So glutathione looks like this. I want you to look over here on the right first. So it's made up of 3 amino acids, glutamate, cysteine, and glycine. And I haven't drawn in the R groups for glutamate or glycine. I really want you to focus on cysteine. So notice here I've written reduced glutathione and GSH. GSH will be the shortened version for reduced glutathione. It's basically G with the thiol group. So cysteine's R group, this thiol group here, has this H here. So we know that this is the reduced form. It can be oxidized and form a disulfide bridge. So if we take two of these, and we oxidize it, go this way to the left, then we can create oxidized glutathione, which is 2 G's, right? And then the 2 S's here represent this disulfide bridge forming. So this is the oxidized form. So basically what happens is that glutathione takes one for the team. What do I mean by that? When glutathione is in its reduced form, it can be oxidized, right? So if an oxidant comes in, an oxidizing agent comes in, reduced glutathione will say, okay, cool, let me get oxidized instead of these other important biomolecules. So reduced glutathione will get oxidized and turn into oxidized glutathione. Okay, so that'll keep happening to protect us from oxidants. So if an oxidant comes along, then the GSH, right, the reduced glutathione, will take the blow and it'll get oxidized and become oxidized glutathione. Now, if lots of oxidizing agents come along, lots of oxidants, what would happen? Well, that means we'd have more GSH, right, this reduced glutathione, get oxidized into this oxidized form, this glutathione, this oxidized glutathione. So we'd have a bunch of GSH being oxidized into GSSG. Okay, so what if this keeps happening? If there are a bunch of oxidants, they turn all of our GSH into GSSG. So now there's no more reduced glutathione left to protect us from the cell's biomolecules. There's no GSH left to protect cell's biomolecules. That's a bad thing, okay? So how do we solve this? Well, we need to find a way to take this oxidized glutathione and remake this reduced glutathione. So we must reduce the oxidized form of glutathione with NADPH. Oops. We reduce the GSSG with reducing power, which is of course NADPH. So how does that actually happen? This oxidized glutathione, if a lot of it's oxidized, we have NADPH come in, will provide the reducing power. So NADPH will reduce the glutathione, and the glutathione oxidizes the NADPH. So the NADPH will come out as NADP+, and then we get the reduced glutathione. Now it's available to protect us. This this step is catalyzed by glutathione reductase. So this step is catalyzed by glutathione reductase. So basically what's happening is that NADPH allows the reduction of the oxidized glutathione to regenerate reduced glutathione to keep us able to fight off these oxidants. Okay, so that's how NADPH and glutathione work together to fight oxidants. Hope that video was helpful. Thank you for watching.